Okay, so we're going to look at a formal way of talking about the things we've actually already been doing, and a way to describe that is called linear modeling, which is just working out the relationship between two variables and using a graph to draw it. It's what you've been doing all along, you just haven't been using that term. So what is a little bit different about linear models is usually only the positive quadrant is used. Often means that the line of our graph also may not start at 0, because we're working with real life stuff here. So we're usually not interested, or it doesn't make sense to have negative values. So we're usually only in the positive quadrant. There's some key elements to this. So first of all, we're finding the rule linking the two variables, which is what we've been doing. Sketching a graph. We're using a graph or a rule to make a prediction or an estimate of one variable if we know the other one. And we're finding the rate of change of one variable, which is just the gradient. So the rate of change is the gradient. So it's exactly what we've been doing, put into slightly more formal terms. Okay, so let's have a go at an example. So we've got a sales rep earns $400 per week plus $20 for every sale she makes. We need to write a rule which gives the total weekly wage, W dollars, if the sales rep makes X sales. So what we should be doing here is defining a variable. So we say let W dollars equal the weekly earnings. So I know it effectively does define our variables there, but it's best to state it anyway. And S equals number of sales. So we should write an equation for that. So the weekly dollars are going to be the $400 that we get no matter what, plus $20 times the number of sales that we make. And of course we could simplify that down further, 400 plus 20s. And we could even realistically lose that dollar sign in front. So W equals 400 plus 20s, that's a rule. Now, B, draw a graph where W versus X. So X, in this case, we've labeled S, but we could call it X as well. X equals the number of sales. In fact, let's go back and do that and make X our number of sales to make it really clear. So let's draw it on we need to do our axes, same as before. Now remember I said pretty much most of the time we're only going to want positive, which makes sense here. You can't have negative money, you can't earn less than 0, and you can't make less than 0 number of sales. So it's important that you label them. So this is weekly wage, weekly earnings, for example, and this is number of sales. Okay, so we've got our axes, but we need to actually plot them. So this is where the 0 to 40 comes in. So we only want X values between 0 and 40. We don't care about anything below 0, and we don't care about anything above 40 according to this. So you can substitute that in to find as our X values, to find what Y would be at those cases. So it's already given you the X coordinate there. So we're going to substitute that in to find Y. So W equals 400 plus 20 times 0 in this case. So W equals 400 at this point, which would give us the coordinate 0, 400. Similarly, if X equals 40, number of sales, we can find Y. So W equals 400 plus 20 times 40, W equals 1200, which would give us another coordinate, 40 and 1200. So they are two coordinates we can easily plot. It helps if we have a scale on our axes though. So 200, 400, 600. Okay, now I'm going to go up in tens on this axis, just because it's easier, and I'm only going to go up to 40 because I really don't care about it after that. That's what I'm interested in here. So our first point is 0, 400, and our second point is 40, 1200, so that's going to be there, and you're simply going to join a line between them. So normally we'd keep going, but in this case we only want those values. It's giving us what's called a domain, defining our outside values, so we don't need to do that. But we should, like normal, write the equation of the line on there. So w equals 400 plus 20x, so that's part B. So you can see there's nothing really anything different so far. It's just in a more formal way. How much does the sales rep earn in a week when she makes 12 sales? So we're going to simply make x equal 12 here, substitute into our equation and solve. So w is 400 plus 20 times 12, which equals 400 plus 240, which equals 640. And of course, we should write a sentence. So the rep earns $640 if she makes 12 sales. And the last one says, if the rep earned $1,000 in a week, how many sales did she make? So again, substitute it in. We're just going to substitute in for W this time. So let W equal 1,000. I'm just going, so that's going to be 1,000 equals 400 plus 20x, 600 equals 20x. X, of course, is 600 divided by 20, which is 30. Therefore, to earn $1,000, the sales rep made 30 sales. And it's literally as simple as that. And it's all the stuff you've already been doing, so there's no need to get worried about having to learn something new. Okay, so continuing on with that lesson, you need to do some practice with that. So there's some questions there from exercise 4J, but we're going to look at the next chapter as well, and we're going to talk about finding a graphical solution that makes two equations true. So when we're solving two equations at the same time or simultaneously, it's something called simultaneous equations. Next year in 10 Advanced Maths, you're going to learn how to solve these algebraically, but this year we're just going to work on solving them graphically. So the good news is to find these solutions, we just have to find a point which makes them both true, which is called, in this case, the point of intersection. So we can use some methods we've already learned. To do this, we just need to find points on the line that make both of these true. Now, it's important to remember that sometimes two equations will never intersect because they're parallel lines. So when this happens, there won't be a point of intersection. So let's have a go at doing a couple of examples. So first one, decide if point 1 and 5 is at the intersection of the lines y equals 5x and y equals 3x plus 2. So to do that, we just need to substitute it in. So substitute point into the equations, so both equations, but do them separately to see if they were on the line. And if you'll remember back to the lesson we did on that, to see if they're on the line, we just need to decide if we substitute the x value in, does it give us the same answer as the y value of the point? So let's do that. So y equals 5x is the first one. I'm going to substitute x equal 1, which is the first part of my point, into the equation to see if it gives y equal to 5, which is the second point of the coordinate. So y equals 5 times 1, which equals 5. Therefore, we can say that point 1 and 5 is indeed on the line. It's on y equals 5x. Done. Move on to the next one. So 3x plus 2. So again, we're going to substitute x equal 1 in. So that's going to give us y equals 3 times 1 plus 2, which equals 3 plus 2, which of course equals 5. Therefore, this point is also on the line. Y equals 3x plus 2. And because they're on both lines, we can say 1 and 5 is on both lines. Therefore, it is the point of intersection. It can only be the point of intersection if it's on both lines. An equation, unless it's the same line, will not, a linear equation will not intersect at more than one point. So if it makes both lines true, it must be the point of intersection. Now, we're actually going to work on now solving these simultaneous equations graphically. So we've got two equations there. So the way we do this graphically is obviously plot them. We have to plot these lines. Now you have to be really accurate when you plot these lines to solve simultaneous equations graphically. Don't be rushed, and make sure it's really, really important that you use a ruler. So I'm going to use the y and x intercept method. You could actually use any method that you like. I'm just going to do that one now. So just a reminder to use the y and x intercept method to make, if we make x equals 0, it's going to tell us what our y-intercept is. So that's going to be 2 times 0 plus y equals 6, y equals 6. So our first point for that line is 0 and 6. And if we let y equal 0, it's going to tell us our x-intercept. So that's going to become 2x plus 0 equals 6. X obviously equals 3. So that's our second point. So we could go away and plot that. Now, I'm also need to do that for my second line. Same situation. So I'm going to let x equal to 0 to find my y-intercept. So that's going to be 0 plus y equals 4. Obviously y equals 4. So that's 0 and 4. I'm going to let y equals 0 to find my x-intercept. So that's going to become x plus 0 equals 4. So obviously x also equals 4. So that's my second point. So now I've got these 2 points, I can plot them, and I need to be careful, as I said. So you're going to use a ruler to make sure it's as accurate as possible. Now that I've got my 2 points, I know where I need to situate my axes, so somewhere there. So I'm just going to label every second one so that it's just a bit easier to read. And I'm probably going further than I need to, but that's okay too. Okay, so plot my points, draw my lines. So my first one is 0, 6, and I might do these in different colors, and 3, 0. So plot my 2 points, draw my line between them. So you can see my line's already not super straight, so we could have a bit of an issue. Just going to change color. So let's plot the second 2. So 0 and 4 and 4 and 0. So I'm already a little bit out of whack. So I could have an issue. In fact, I'm going to redraw that one. That's so bad. And I'm actually going to redraw my first one too, because that was really bad as well. Okay, so they're a little bit better, but they're not super awesome. So you can see where it crosses, where it's supposed to cross is there. And I've got a little bit of a dodgy line, so it's not perfect. But this is where my solution is. And we can see that that point there is 2 and 2. Also, don't forget to label your line. So this line is 2x plus y equals 6. Notice that the lines cross. Don't get confused when you're labeling. You can draw arrows if you need to, or a line, but you can also just label it. So to get the answer, read the solution from the graph. If your graph is accurate, you're going to be able to do it without any problem. So 2, 2 is where the lines intersect, or the point of intersection, which is the solution to these simultaneous equations. So just a reminder, it is important to remember to get this really good. Axes must be accurate. Also, your lines must be drawn accurately. Okay, so you're going to go on and you're going to do these exercises listed here from exercise 4K as well, and watch the parabola